All right, hello. Good afternoon, everyone. My name is Ting Liao. I'm assistant professor in the Department of Systems Engineering at Stevens Institute of Technology. I'm leading a human AI interaction design lab, so I get exposure and use methods from both engineering design and systems engineering, and you will see that in my presentation. Today, I'm excited to share my work on shaping human trust in AI-assisted design ideation. So when I began my research journey as a PhD student at Stanford around 2016, 2017-ish, autonomy felt just around the corner, of course in Silicon Valley. Besides being fascinated by the capability of AI in concepts and geometry generation, I was really driven by one simple question. When should we trust an AI system? At that moment, autonomous driving was front page news, and we staged different edge cases in the driving simulator and see whether people relied on automation versus intervened their decisions. And since then, AI has evolved, and I have worked with voice agents that scaffold information retrieval and cognition to now large language model that co-design with human beings in engineering. So as AI advances, the research questions that I am passionate about answering remain: how do human users form trust in AI, whether similarly or differently than they do for other human beings? Accordingly, how can we, as engineers and design researchers, facilitate the process for calibrated trust, potentially by formulating new design principles and mental models, or will we surprisingly see people still use the same heuristics and mechanism to trust and trust AIs and other virtual avatars? So there are many research perspectives and methods related to trusting AI, including explainable AI from computer science community for a better interpretability, and assurance engineering for safety and reliability. Echoing Zoe's opening remarks yesterday, I believe that trusting AI research benefits from a system modeling and system design perspective. First of all, trust is a complex social technical construct that dynamically forms with input and feedbacks, as a system does. In addition, trust is shaped by so many different factors, including system performance, interface design, problem context, user emotions, and cognition, of course. So that really needs a systematic approach to examine them fairly and holistically. And to do such, we envision a modular testbed that lets us vary relevant design attributes and measure their impact systematically. In addition, our work does consider AI to play a proactive role, prompting and guiding design generation instead of just another tool of execution. And that actually, or increasingly reflects the real practice. So as a starting point, we designed and developed the testbed, referred to as AI Design Assistant, ADA, progressively from a baseline robotic model and an existing data set of 672 text-based concept descriptions for sustainable design, and to Llama model and GPT API, making ADA more responsive in supporting creative design. Partially due to the nature of the training data sets and the domain-specific model, the theme of the following study centers around sustainability and early-stage concept design. And building upon the testbed, ADA, as a proactive collaborator, it presents a chatting interface I'm showing on the left, and greeting users and prompting design prompts when a user or when a participant inputs an idea, it validates the input to see if the input actually aligns with the prompt instead of just random inputs people tend to have. And then it evaluates the input on novelty, feasibility, and sustainability, which are relevant to this particular design theme. And that follows a parallel structure. So when people have any inputs, the system does the evaluation in parallel, and the combined results is synthesized into detailed critiques and feedback for the user. By leveraging ADA, we identify 3 key attributes from a variety of design categories, including aesthetic appearance, system performance, and agent behavior. So I definitely acknowledge that there are many more attributes that we can possibly explore, but those are just the starting phase for our project. So aesthetic appearance has been shown to create social presence when people forge collaboration. So and we consider that to be an important factor when we kind of form collaboration between a human and AI as well. Performance is recognized as the dominant antecedent for trust in automation in general. And we manipulate it as the agents provides detailed feedbacks about designs versus a simple score and overview for participants. And lastly, we incorporated empathy as one type of agent behavior, whether agent recognize emotions expressed by participants during interaction and provides empathetic responses. So empathy has been emphasized so much in the design process, and as Dr. Samas mentioned this morning, it's something that robots may not be able to present very accurately. So we incorporate that. Aesthetic appearance, performance, and agent behavior by presenting empathetic responses. For each attribute, we incorporated 2 levels. And for example, a humanoid avatar versus abstract icon, detailed feedbacks versus scores and overview, and empathetic responses versus non-empathetic ones. We used the factorial design to create 4 distinct design versions of combinations to represent different attribute level. To understand how system attributes influence trust and their relative importance. So this is where the system thinking kicks in. So we conducted a human subject experiment where each participant followed a looped structure. So they had they all interact with all 4 distinct versions that we created. So for each of the 4 versions, they were introduced to a sustainable design prompt, and they iterate on the design with feedbacks and inspirations provided by Ada, the assistant we created, but look and behave slightly different. They also filled out a survey about that specific agent after interaction, so we can collect their trust attitude and their also satisfactions and other experience reporting. So we collected valid data from 56 valid participants, and none of them had extensive engineering design experience, so we consider all of them as novice designers. But they all reported to be super confident about their experience and familiarity with bots, so that's a kind of interesting observation. So we did observe group differences for self-reported attitudes, including perceived bot effort or system efforts, empathy, trust, enjoyment, helpfulness, and usefulness of the system. And more interestingly, we found this consistent trend. This graph has this U shape for all the self-reported metrics or self-reported attitudes in the post-interaction survey. So apparently version 1, the one with all the high level, like a high performing one, like humanoid or avatar, detailed description, detailed feedbacks and reasoning, and empathetic response score the best. But on the other side, the version 4 with overall score and feedback and abstract icon, but empathetic responses also score the second. So the mixed model show kind of similar thing. It shows that who we are and where we come from, including the initial trusting attitude and age, have significant impacts, as well as empathetic behavior on trust in the ADA system. And in the analysis of trade-offs for performance, trade-off analysis for preferences, human users value performance the most, and that aligns with the existing literature in trusting automation. But on top of that, recognizing emotions and building social connections may be the low-hanging fruits that could possibly compensate for inferior performance, as recognizing emotions does take computational effort, but not as much as improving the algorithm. So we collected a rich set of data and are currently exploring how participants' design performance and trust evolves dynamically, either diverging or converging with what AI suggested under influence of design attributes. As a hint, we observed this symmetric pattern of novelty and feasibility score over time at an aggregated level across versions. So participants were prompted to iterate at least twice. So we have, if you look at the first 3 data points, novelty increased at the cost of feasibility. But after that, some participants continued to engage, and that's where scores started to fluctuate. We are diving deep into dynamic interaction with ADA for individuals, which by considering sentiment and creativity over time, we envision that result will enable future adaptive system and design guidelines for personalized support and coaching. Yeah, that brings to the end of my talk, and I would like to thank organizer for this opportunity to talk about my research, and I'm happy to talk more and answer questions after this.